Digital Technologies for COVID-19 seminar series. Our speaker today is Marjorie Friedman. Marjorie is a research team lead at the Information Sciences Institute, which is part of USC. She has degrees in both linguistics and computer science from Cornell University. And at ISI, she's been leading a number of large research efforts. So in three different DARPA programs. So the AIDA program, Kairos, and ACID efforts. And so these are major research programs where she's sort of taken the lead in terms of managing these programs. She has been doing quite a bit of work in terms of natural language processing with respect to these programs and stuff. And today she's going to be talking about work she's been doing on information extraction, and specifically the title of her talk is Task-Specific Data Annotation for COVID-19. So I'm going to turn it over to Marjorie.
Hi everyone, I'm going to start sharing my screen now. And Craig, can you confirm that you can hear me and see the slides?
Yep, it looks great.
Great. So thanks for having me today. So I'm going to talk to you about using information extraction to organize COVID data. And most of the focus of the talk is going to be about our early work and trying to collect data that we can use to train an information extraction system. But I wanted to talk to you about what information extraction is and why you might want it in the COVID arena as well. So information extraction is a subfield of natural language processing with the goal of transforming text into structured information. As Craig mentioned, I work on a lot of different programs. Most of them focus on open domain news-like material and having a goal of taking that text in the newswire and making it look like something that you would put into a database record. And so I have an example here pulled from that type of work where we have a sentence from a recent news document and extracting that sentence includes a violent event. The location of that violent event is the city, the region, Idlib, this terrorist organization participating in it, and then that we've also observed that HTS operates in that region. One of the things about putting examples on slides is that the examples make the problem look really easy. And so the answer to why information extraction is hard is that language is really ambiguous, in part by design, so that we can be flexible in what we communicate. And it's constantly changing. And that makes taking this flexible, evolving representation of communication and making it into a very precise database record a hard challenge. Why do we want to do that? The structured representation isn't the end. What that structured representation lets you do is apply a lot of downstream analysis and downstream visualizations to the task. And so you can think about information extraction as a way of making language data available to data science. And so we can see who is operating in the place that is Idlib. We can see where in the world there are violent events happening. We can plot these on timelines and on maps. And so that's kind of the general space of how you would go to use information extraction. Typically, information extraction is a mix of general purpose tools about language and general purpose machine learning. So people work on finding the syntax of a sentence, understanding the semantics of the sentence, knowing how to dereference pronouns. So who does he refer to in a sentence? What does it refer to? And then with kind of the increasing and takeover of deep learning, representation learning itself. When you get rid of these in-between steps and try to just learn a representation of the language language. But if we want to get to that final task space where we have these labeled relations and events, labeled entities, we end up using task-specific supervised machine learning. And some of the task-specific areas that people work on there are named entity recognition. So can you find the names of people, the names of organizations, the names of places? Can you find certain types of relations, where an organization is operating, what the headquarters of a company are, where a person was born, and certain classes of events? Who met with whom, where did the meeting happen, who's traveled where, and when. And a longstanding challenge with this task-specific nature is that new domains require new classes. So we start out in this open news politics space, and we're interested in people and places and organizations, and we work on that for a long time. And then we say, oh, somebody wants us to pay attention to restaurant reviews. And now we need food and allergies and beverages. And in a more serious example, we have a problem like COVID, and we are interested less in people and places and organizations and more in symptoms and treatments and infection vectors. And each of those new classes requires class-specific supervision. And so when we go to a new domain, we need new annotation, we need new human-created examples of the data that we're interested in. And in one of the kind of lines of research that I've been working on, one of these larger projects, we've been thinking about how we can make annotation creation more effective. And in that framing, we can think of COVID-19 as a new domain. So how can we make it possible to create new annotation for the COVID problem? Before I go any further, I want to recognize that there's a large community of people working on natural language processing specifically in the medical domain. And that's actually a different subfield of NLP than what I work on. But if you're interested, there's a lot of information out there, and I imagine the seminar series has had some speakers from this community. I think the major difference and the major thing that we're trying to pay attention to is that we're doing our data creation by non-domain experts. And so in a lot of the biomedical NLP tasks, there's an assumption that you have medical experts or scientists who are creating the training data for the machine learning algorithms. In the type of information extraction that I do, there's an assumption that you might have a sophomore English major working with you to create this annotation. I mean, that gives us a much broader pool of people to hire to do annotation. And we thought it would be interesting to see what we could do in the COVID space as well. So standard approaches to information extraction annotation. I think the canonical information extraction kind of data set is this data called ACE 2005. It was released by the Linguistic Data Consortium. And what they did there is identify a documents collection. So it's about 600 documents, and develop very careful guidelines that map text to the ontology classes or types, those relations and entities and events that you're interested in. The primary goal in developing those annotation guidelines are agreements between people, the speed at which people can do the tasks. You want to, more annotation is usually better. And then people are going to disagree sometimes, either because they make mistakes or because it is hard to map language to these classes. And the annotation has a goal of, the guidelines have a goal of having a code book that you can refer back to and decide who is right. And so the adjudication process when people disagree is easy. And then the annotation is done by, for every document, annotating all classes in all instances in this ontology. And there are a couple of limitations with this approach. So the guidelines are often pretty unintuitive. And so the annotators needn't be experts in the domain they're annotating. It can be kind of but you have to train them a lot to make the types of decisions and distinctions that you're asking them to make. And then the guidelines end up yielding what look like inconsistencies, both to models and actually to downstream analytics. And so you have these very kind of, if you go back, you can trace through why this is the right answer, but it doesn't look like what you would think the right answer is. And then because we're annotating in this case over a whole document, the number of positive examples that we get for training machine learning is going to be proportional to how frequent that class occurs in text. And so some classes are going to be very, very frequent. In this kind of general news domain, you can imagine that meetings are very, very frequent. They occur all over the place. Other classes are going to be pretty infrequent. So there were a series of event types about the criminal justice proceedings, and acquittal is one of the types. Acquittal is very rare. And so if your goal is to cover your whole ontology, it can be very difficult to get enough examples. And having those classes where you have only a small number of examples are really hard for the model to learn. It's hard for it to distinguish between the noise of, oh, I just saw one example of this, and what it should think about in the future. So there are some common alternatives. So a lot of people work on active learning. This lets the initial model select examples that it would like annotated. But doing active learning requires enough data to have an initial model. Recently, there's been a lot of work on transfer learning, but this usually assumes that you have some nearby similar task to transfer from. And so at least in the spaces that I was working and am working in, we don't have that nearby task for COVID. And there's also a lot of work not referenced on this slide in crowdsourcing and trying to use frameworks like Mechanical Turk to hire people out there and give them, 50 cents a sentence to annotate and build up an annotation. But getting that to work at scale for very detailed work like information extraction and annotation can be challenging. So what are we doing? We're referring to it as domain-targeted annotation. We try to write broad intuitive guidelines, again, focusing on this. We want what we tell people to be easy for them to understand, and we're hoping what the classifiers learn to label will be intuitive when we look at the output. We want the annotation to be dense in per-type examples, and we achieve this by asking the annotators to try to find the concepts that they're interested in. So people are pretty good at, given a description of something that they're looking for, going to search for it in a corpus. Google's taught us all to do that really well. And so rather than giving people a collection and saying, just go through this sentence by sentence and annotate, we give them classes and say, go find positive examples for us. And they annotate 10 examples per search term. This is useful because it means in the cases where you have polysemy, you have the same word meaning two things in different contexts. In kind of the COVID case or a medical case, shot is a nice example. And so shot can mean a vaccination. It can also mean that there was a shooting and guns were involved. And our classifiers need to learn the difference between those two instances. And if we search 10 times, probably we'll see both. And if we don't, it suggests that whatever data set we're looking in, most of the time, it's one type or the other. We also allow the annotator to skip confusing examples. That speeds things up a little bit for us. That gives us more accurate training data, I think. And we're aiming for maximal information per sentence rather than speed at the annotated class. And so some portion of the guidelines that are provided in traditional annotation tasks are designed to say, in these cases, you need to mark some X, and in these other cases, you need to mark Y. And that means you have to make less decisions. You have to highlight less things in the text. But it gives the model less information. And if a lot of your time is actually spent reading the sentence and understanding it, we want to get as much information as we can out of you. And so we ask people to tag as many clues as they can. And in fact, we add a tag that's just, this helps me understand the context, and so probably you should pay attention to this word. So needle might be a clue for vaccination. So how did I start working on COVID? So in March, late March, early April, there was a release of challenge problems through the Allen Institute called the COVID-19 Research Challenge. They released a bunch of tasks that were questions that experts wanted answers to. And a lot of my project work at ISI is somebody gives me a task and we need to apply information extraction to that task. And so we were asked to look at these tasks and see what we thought. And we looked at them and said, well, there's no ontology. There are no set of classes that we're trying to find. Even what it looks like isn't well covered by the types of things that we're aware of. And so probably we can't be that helpful right now. But we have this area of looking on adaptation. And here's a real problem that we could try to adapt to and maybe create data that could be helpful as we were doing that adaptation. To give you a sense of what these tasks look like, this is one of the sample tasks. This is one of the first sample tasks, I think. And so some of the questions are outdated, but you'll see these tasks were designed so that the crowd could try to answer them. They have a mix of terms that probably only experts know, but some questions that I could go out and look for. So I could look for national guidance and guidelines about best practices. And it seems like some of them we might be able to help the search. We might be able to help the data organization by providing information extraction output if only we could do the information extraction. And so to see if that was possible, we started this experiment. We manually reviewed the tasks and data set and identified relations and events that we believed would support a task-related question. And that was critical. We didn't want to say just, what can we find in this data? We said, experts have told us what they want to find. Let's try to find it. We also wanted to acknowledge the limits and assumptions of our approach. So the information extraction tools that I work with work much better if the answer is explicit in the data. They have a hard time inferring from lots of background knowledge. And so we were looking for events and relations that we believed would be mentioned explicitly in the data. And we were looking for things that non-medical experts could annotate, because those are the types of people that we employ for annotation. And so where we are right now is annotating. This is in progress. We have one person working on this a couple hours a week. And then once we get that annotation, our plan is to train models and assess the model performance. Assessment is going to be hard here. We don't have a gold standard. And so I think our assessment is going to look like, do these extractions actually look like they answer the relevant questions? And are they correct? If we go back to where they were found, are they correctly finding the information? I mentioned that we tried to put together relatively intuitive guidelines. These are examples of what our guidelines look like. We have a relation or event name in the left column, so incubation period or cross transmission. We have a short, typically phrase or sentence description. Sometimes they get a little bit longer. And then we have the things that are involved that we're interested in for that relation or event. So we have incubation period, and we're interested in a disease's incubation period and what that period is. We have persists on surface. We're interested in what's persisting, what surface is persisting on, and for how long. And so this is an example of what I've talked to you a lot about annotation without showing you what annotation looks like. This is an example of a screenshot of our actual annotation tool. We're using a great annotation tool that I have a reference to, with the key feature being that it enables the search that we want to do inside of the tool. And a less clear thing about this annotation tool is it labels everything as a negative example when it's a positive example. And so you should just ignore those negative examples, but you'll see annotation involves highlighting these strands of text. So Merkel cell polyomavirus as an agent of some relation. And this is a symptom of kind of that's not highlighted here, but that's the type of relation it is. And so where are things now? This is the number of positive and negative examples we have per annotation type. And you'll see it's still limited. This is still ongoing work. An interesting thing that you start to see, even with a small amount of data, is for some cases, our search is very effective. So for asymptomatic cases, almost everything that our annotators found was a positive example. For infection prevention strategies, somewhere between a quarter and a third of what we find when we go to search for prevention strategy isn't a positive example. It's a negative example of prevention strategy. And so that's going to make a simple term-based approach to doing this type of extraction harder. And this balance between positive and negative examples is something that we'll push on as we start to work on the modeling. I mentioned that this annotation is still limited, but it's in the range of community benchmark sets. Not at the high end of that range, but I mentioned this ACE corpus earlier. And so that's 600 exhaustively annotated documents that served as the community benchmark for 15 years. I've omitted the 3 very frequent event types that have over 500 examples because they made the slide unreadable. But on the right of the slide, you see the number of positive examples in ACE. And then in teal, on the left of the slide, you see our positive examples. And we're certainly not at the top. We certainly have a way to go with our annotation to get to even median. But we're also not at the bottom for at least 6 of the relations. So for at least 6 of the relations, we're inching towards enough information to train a model already. And so what's next for us? We're continuing annotation. We hope to get to about 100 labeled examples per class. We plan to release this annotation, so you should email me if you're interested in an early release. We're just kind of holding off until we're sure that we have quality data to release to people. And then we'll plan to test this on standard extraction models. I'm now open for questions.
Okay, great. Thank you, Marjorie. That was quite interesting. So people can post their questions in the Q&A, and we'll take questions as they come in. Let me start off though by asking my own question, which is, so you had in a slide a few slides back, you had a list of relations here. So how did you actually come up with this particular list of relations that you ran into?
Yeah, so we did that by reading these tasks. And I think one of the interesting things about this AIT challenge was we often talk about wanting to create annotation and information extraction models that are useful to the end users. We're not creating these for ourselves. And so a slide on this. And so we said those task-related questions that are available through this leaderboard that somebody is hosting guided how we chose the relations. And then we pushed these second 2 steps, which boiled down to, do we think we can do them? Do we think if we get this annotation, we'll be able to make use of it, and do we think we'll be able to annotate it? And so that's, do we think these are things that will appear explicitly in the type of data that we have? And do we think a non-medical expert can annotate them? I'd love to hear from anyone who has suggestions of other relations.
Okay, so we do have a question in the chat. So have you seen the work done by Kegel on this? And there's a link to it in the chat under .com, COVID-19 contributions.
So I have seen some of it, and in fact, that is, the kind of challenge that we started our work on came from that challenge. And so it wouldn't surprise me at all if there were other parallel efforts going on with similar things. But yes, and it's what they released is a great data resource.
And here's a related question, which is, is there a parallel effort on modeling information extraction annotation for contact tracing?
I'm not sure. I think that would be an interesting thing to try. I think getting the data would be hard. If I had to say why would this be hard, it's that so much of contact tracing starts to grapple with privacy issues. But it would certainly be interesting to see.
And another follow-up question, which is the British Medical Journal has been extensively annotating COVID datasets as well. Have you considered teaming up with that scientific team?
I have not, but that's an interesting pointer, so thank you.
Okay, let's see. Do we have anything else currently? I have perhaps a more general question, which is, just for people that maybe are not that familiar with the sort of the purpose of doing this kind of extraction. So once you've done this, I mean, you've extracted these different kind of relations. I mean, how is it then used to answer the questions?
So I think that would vary by questions. And so you, in general, would run the information extraction over a lot of data. And so, there, as I mentioned, there are other efforts going on. IARPA just had a call of helping to organize, all of the massive amount of scientific literature that's coming out. And so you would take your model and set it to process I don't know how many thousands of papers that are coming out, blog posts that are coming out. And then use these extractions as, if you were interested in transmission seasonality and reports of transition seasonality, you might count the frequency in which cases you have transmission in spring versus transmission in fall. And so I think there's usually a question-specific mapping from an information extraction element to the question.
Okay, great. And perhaps one other more general question as well, which is, so in terms of the annotation work, can you give a sense for how long it takes to annotate each of these different sentences or documents that are coming in? I mean, I assume it's done at the sentence level, but you probably have, in a technical article, there's a huge number of sentences. So, what does it take to annotate a sentence? What does it take to actually annotate a document?
Yeah, so one of the things about it that's interesting from a human factors perspective is people are very different at this task. But usually, and our specific search is highlighting a sentence. And so a person's really only supposed to mark the sentence that the search returned, although they have the context of the document to look at. I would say we expect it to be a couple of minutes a sentence, especially in this type of arena where we have a non-expert who has to kind of understand what's going on. You're dealing with some unfamiliar terms. So 2 to 3 minutes a sentence to do all of the highlighting, to decide, oh, did I get it right? That is averaged over a number of sentences because people take breaks. You can't do this over and over and over without a break.
And How does it work? So you had a set of relations that you're basically trying to extract from these different documents. I mean, how do your annotators go about this? Do they search for the specific terms that are sort of mentioned there to then see if there's a corresponding sentence, or do they just read the document from beginning to end and say, okay, does it mention any of these terms?
They search for the terms. So for incubation period, which is a hard one to come up with examples for, at least for me, but for incubation period, they might search for incubation. And then they'll get a set of sentences that have incubation. And they will annotate 10 of those sentences. And then some of those sentences might spark other terms that they're interested in searching for. And then they search for the next term and mark those sentences.
I see. And then I guess sort of a final question that along those lines, you know, if someone wanted to help out and volunteer to do annotation, is that an option? Can they reach out and
yes, people are welcome to reach out and volunteer. We currently have one paid annotator, but we'll take volunteers too.
Yeah. Okay, great. All right. Well, thanks for the talk today, Marjorie. I think we've answered all the questions in the Q&A. And so I think we're going to end the webinar at this time. So thank you very much for the great talk today.
Thank you.
And thanks everyone for joining.